Damn, son, where'd you find this?
In this section, we are going to be looking at rational exponents, that is, exponents in this form. We'll start by looking at a special case where n is an integer. So first we'll define just what we mean by exponents of this form. The definition to the left is equivalent to the definition on the right. When evaluating b exponent 1 over n, we are really asking what number did we raise the n to get b. Often b to the power of 1 divided by n is called the nth root of b. So we're going to look at two different methods of dealing with rational exponents. Using either of these forms allows you to evaluate more complicated expressions. In the first example, you have 1 over the denominator inside of the parentheses as an exponent, and you have the numerator as itself outside of the parentheses as an exponent. In the second example, you have the numerator as an exponent inside of the parentheses, and you have 1 over the denominator outside of the parentheses as an exponent. Finally, be careful not to confuse these two expressions. Try pausing the video and solving these on your own. So for the first question, all we're asking is what number did we square to get 25? In this case, it's pretty easy to get. We square 5 to get 25. So when I see an even number that has an exponent, first think of a number like 2 that it can be broken up into, because every even number can be broken up into 2's. And for odd numbers, I'll usually think of a number like 3 or 5, because lots of odd numbers can be broken up into 3's and 5's. Now, this part actually doesn't have an answer. I put it here to make a point. In this case, we're asking what number do we raise to the 4th power to get negative 16, except we know that raising any number to an even power will make it positive. So in this case, there's no answer. For the final question, there is a number that can be raised to odd power 3 to get 16. So there is an answer. So we have a to the power of 2 over 3, 625 to the power of 3 over 4, and 243 divided by 32 to the power of 4 over 5. To solve the first question, 1 over the denominator inside of the parentheses as an exponent, and you have the numerator as itself outside of the parentheses as an exponent. Or have the numerator as an exponent inside of the parentheses, and you have 1 over the denominator outside of the parentheses as an exponent. I usually prefer using the first method, but either one works. For the last question, because it is a fraction, the exponent, of course, will apply to both the numerator and the denominator, and then from there do the exact same method for the top and the bottom as you did with other questions.
Oh, pull it up, Jamie.
So for the first question, we have w to the power of minus 2 divided by 16v to the power of 1 divided by 2. And everything is to the 1/4 power. And the second question is x squared times y minus 2 over 3 divided by x minus to the power of minus 1 over 2 times y to the power of minus 3. And that is to the negative 1/7 power.
So first multiply the outer exponent by the inner exponents and any numbers that are inside of the parentheses. Evaluate each variable individually. So we'll have negative 2 times 1 over 4 is going to be negative 1 over 2. 16 to the 1/4 power is 2. And 1 over 2 times 1 over 4 is 1 over 8. And then the variable with the negative exponent goes to the bottom, and we're left with 1 over 2v to the power of 1 over 3 times w to the power of 1 over 2. We'll start by switching the variables with negative exponents from the top to the bottom. So the ones with the negative exponent at the top will go to the bottom, making it a positive exponent, and the ones with the negative exponent at the bottom will go to the top, making it have a positive exponent. So first we'll multiply the x variables together, which will mean that the x exponents will add, and we'll divide the y variables together, which will mean the y exponents will subtract. And then, since the outer exponent, negative 1 over 7, is a negative, it will sort of flip our equation upside down, and it'll make the outer exponent now positive. And now multiply the outer exponent, 1 over 7, by the inner exponent.
Boom, perfect timing.